Hello everyone, welcome to the session on C Programming Laboratory. I am Naveen Spagat, working as Assistant Professor in Department of IC, SDM Institute of Technology, Ujjain. In this session, we will discuss on BubbleSort algorithm. The experiment 11 in the C Programming Laboratory is to develop a program to sort the given set of n numbers using BubbleSort. The aim of the experiment is to sort the array elements in ascending order or descending order using bubble sort algorithm. Prerequisite: the student should have the knowledge of array implementation and knowledge of swapping of two numbers. Sorting. Sorting is ordering a list of objects. Consider the array here. The array contains the data elements which are not in order. When we apply the sorting techniques, the elements will be sorted. That is, in this case, the elements are sorted in increasing order. So we will now discuss the bubble sort algorithm. Bubble sort is a simple algorithm which is used to sort a given set of elements in form of an array with n number of elements. Bubble sort compares the entire elements one by one and sort them based on their values. Consider the array here. In each iteration, the heaviest element drops at the bottom. So in this array, the heaviest element is 6. So the 6 should reach to the bottom, and the next highest element is 5. 5 should reach this position, and next highest element is 4. 4 will reach here. Then 3 will reach this position, 2 will reach this position, and 1 will reach the topmost position. So as the heaviest element drops to the bottom, the lighter element moves upward. As the bubble moves from downwards to upward, the lighter element moves upward. Hence the name bubble sort. If the given array has to be sorted in ascending order, then bubble sort would start by comparing the first element of the array with the second element. So in this case, the first element is compared with the second element. If first one is greater than the second one, then interchange the elements. Then 1 will move to first position and 5 will move to the second position. If first element is greater than the second element, it will swap both the elements and then move on to compare the second and third element. In this case, in first comparison, 5 will move to the second position. Then 5 and 6 are compared. So 5 is less than 6. So no need of interchange. If we have n elements, then we need to repeat this process n minus 1 times. So in this diagram, we have 6 elements. It means we have to process n minus 1 times. That is 5 times we need to do the process. So observe this diagram stepwise. The same elements have taken here 5, 1, 6, 2, 4, 3, the first element. Initially we will compare first element with the second element, 5 and 1. So 5 is greater than 1, so interchange. 5 will go to the next position and 1 will come to the first position. So then 5 and 6 are there. 5 is less than 6, no need of swapping. Then 6 and 2, 6 is greater than 2, so exchange, so interchange the values. Then 6 and 4, 6 is greater than 4, again exchange. Then 6 is greater than 3, so again interchange. So at the end of this iteration 1, so the element 6 is at the highest position. Element 6 is at the highest position. And in the next iteration we will skip the last element. We will consider only 5 elements. Again start with the first element. First element compared with the second. 1 is less than 5. So no need of interchange. Then 5 and 2. So 5 is greater than 2, interchange. 5 comes to the position 3 and 2 comes to the position 2. Then 5 will be here. 5 and 4. So again interchange. Then 5 and 3. Again interchange. So in the second iteration 5 will reach its position. Then in the third iteration we will skip these two values and consider only 1, 5, so 1, 2, 3, 4 positions. Only 4 positions we will consider. And it goes on. At the end of n minus 1 iteration, means in this case we have 6 elements. So after 5 iterations, our elements will be in a sorted manner. So we'll see how the program will look like. So as I said earlier, so the student should have the knowledge of implementing the array. So initially we need to read the array elements, ask the user to enter number of elements, then enter the data elements into the array. And here the unsorted array, whatever the values we entered, that will be displayed. So this part will be the BubbleSort algorithms implementation. So as I said earlier, there will be n minus 1 iterations to complete the sorting of elements. So if I have 6 elements, 5 iterations need to be taken. So for that the loop we have written I equal to 1, I less than n, I plus plus. So then for comparison purpose, comparing between first element and second element, then second element and third element. So we have written the inner loop, j equal to 0, j less than n minus I, j plus plus. So this part will perform the swapping operation. If a of j is greater than a of j plus 1. So for example, in the array here, so j equal to 0, j equal to 1, the position indexes, j equal to 0, j equal to 1. So a of j, that is a of 0 is 5 and a of 1 is 1. A of 1 A of 0 is greater than A of 1. 5 is greater than 1. Yes, true. So in that case, we will perform the swapping operation. If the value is not greater than the second element, then no need of performing the swapping. So at the end of the n minus 1 iterations, the elements will be sorted and we will display the sorted elements at the end. Okay. We will now see the execution of the bubble sort algorithm. Here I have implemented the same program which I explained. Let's see the execution. Here it is asking the user to enter the number of elements. I will say I'll enter files. Enter 5 elements into the array. Now what are the elements of the array? For example, 5, 4, 3, 2, 1 are the elements I have entered. So it is in the output it is displaying the unsorted array is the elements which I have entered 5, 4, 3, 2, 1, and after the sorting algorithm applied to the array, it will display the output. The sorted array is 1, 2, 3, 4, and 5. So in this case, I have taken the array size as 100. So up to 100 elements you can provide. But we will ask the user how many elements you want to enter. So that is what we will read it as n. Then that n number of elements we will read. For example, if n is 5, just now I entered number as 5. So that will be taken to the n, and then n number of elements will be read to the array E. Then unsorted array is displayed here. Then from this for loop, the BubbleSort algorithm concept is implemented. Then at the end we will display the sorted array. So this is the implementation and the concept of the BubbleSort algorithm. In the next session, we will take up one more experiment under the arrays concept, that is binary search. Thank you.